So we're actually going to cover a couple of different types today. First one that we're looking at, which is up here, substitute for a variable, is a type, but it's also a tool in a way. There may be other questions, even some that we have done, where you could have done a substitution part to it. Like sometimes it's obvious you're going to substitute, sometimes it's not, and sometimes it's not. It's just a matter of making the question easier to do. That's why you do it. It's not like you have to. It's not like this is a type. So these can mix in with some of the other ones. I mean, we've already done a lot of volume questions, and you're going to notice that I think both that we look at right now are volume. So if you don't recognize it as a substitution and you start solving it, you might just find it to be too hard. You might be able to do it, but you'll probably get stuck on something. Excuse me, you'll be missing something that you need or something like that. Okay? So it's best if you recognize when substitution is the right trick to do. But like I say, these ones can sometimes cross over with the other types, at least a little bit, because, you know, as you can see, it's measurement, it's volume, which we've already done. So you might just say, oh, this is the volume one and not recognize it. There's one sort of tell, like both the two examples that we look at, once we've done them, you can go back and see it's obvious, I think, that it's a substitution. But again, without some practice, you might find it to be tricky. Anyway, let's dive into it. Gravel is transported by a conveyor belt at a rate of 2 pi meters cubed per minute. What does that mean? Not what does a conveyor belt mean, but like what's it giving us right off the bat? Increase in volume. How do you know it was a volume?
Because it's like gravel will like take up space, and also it's in meters.
Yeah. So if I zoom in here, I mean, it says it's a rate. Whoops. It says it's a rate, but it's meters cubed, so it's a volume, and it's per minute, so that's a rate. If it doesn't use the word rate, I still know if it's a rate by the units. The units can tell us so much. Okay. And sometimes I wonder if, you know, I'm pointing out things that are obvious, but I think that's what will make you successful, is by building the right habits, like I said on the first day of this stuff. And the more you observe and the more quickly you observe it and the more easily you observe it, the easier all of these just become, okay, is what I think. So this is a rate and it's dV by dt. We could write that down right away. dV by dt equals 2 pi meters cubed per minute. So it falls and forms a concise pile in which the base radius of the pile is always 3/4 the height. So what shape is this talking about? Yeah, it would be a cone. I mean, you can imagine if you were pouring sand, it would kind of form a cone-ish type pile. It would be approximate. It wouldn't be perfect, but mathematically this one will be perfect, I guess. Okay. And then it says part A, which is what we're going to start with here. How fast is the height of the pile increasing when the height is 2 meters? So it's giving us height, and it's saying to find what? Yes, so the change of height, the rate of height, which is going to be dH by dt, right? Okay, so we're talking volume here. Anybody know what the volume of a cone is? Back in grade 9, you didn't have to memorize these. We usually try, because you got a formula sheet for EQAO, right? And for the final exam and for the test and everything. We usually try to explain them, but it kind of goes over your head in grade 9. But now, I bet you could figure these out without memorizing them. So a cone is based off of what shape? A cylinder. A cone is related to a cylinder. They're both circular. And any shape that has a base and then goes to a point, like the other famous one is a pyramid, and pyramids can have different types of base: triangular base pyramid, square base pyramid, rectangular, octagonal base pyramid. Like you could have all different kinds, right? They're all related to the prism that has the same base shape in an important way. And the cone, because it's circular, is related to the cylinder because it's circular. What's the relationship? It's 1/3. And so now you're like, but then I have to know the formula for volume of a cylinder. But volume of any prism-like shape, which is prisms and cylinders, is the area of the base shape. So what's area of a circle? Everybody knows that, I hope? Not 2 pi. That you've put the circumference and area together. So it's just pi r squared. Very good. So we already said it's 1/3 pi r squared. But what's the other part for volume? Times the height. So see, you can make these up if you just have that connection, that understanding of how they are built. That to find the volume of anything, you take the base shape and multiply by its height or its length if it's lying down, however you think about it. Right? And then the relationship between the ones that go to a point or the ones that go straight up is always 1/3. So pyramid's 1/3 of the similar prism. And then you memorize sphere and you've got all of them basically. Okay? So, but we did say that any unconventional ones we would give to you along the way. So what do we notice about this? I'm given dv by dt. When I take the derivative, I'll have a dh by dt. That's what we're finding. I'm given h. What's left here? R. Do we know anything about R? What do we know about it?
That it's 3/4 height.
So in this case, it's 3/4, and if my height is 2, whoops, 3/4 of 2, which is 1.5. But what happens when I take the derivative? Is it? The radius is going to increase, don't you think? But you might have thought it was constant for a reason. Why? Anybody know? This is the stuff that you have to be able to come up with as you're working through these questions. This is what we have to notice and observe, I think. What do we know about how fast it's increasing, huh? It's always 3/4 of a height. So if the height is increasing, it has to increase along with it, right? We can think of it that way, yes? What else? There's a couple other things. First of all, if I take the derivative now, what do I have here? Well, it's going to be, but it's going to grow at the same rate as the height. So it's not going to stay this, but it's going to grow. I'm just saying this is product rule, right? So you got to recognize that. Makes it a little bit trickier. But what else? When I do it, I'm going to get a dr by dt. What do we know about that? Like we said, it's increasing, but are you given it? Could you find it? Maybe. But there's an easier way. And this is where the substitution comes in. So this is not really useful. What I want R to be is 3/4 of h. And this is the substitution that happens. So this is a substitution question because we're given one of the measurements in terms of the other. If you're told something like that, is 3/4 of the height or is twice the something, I'd be like, ooh, I might need to substitute in this one. You might not, but you might. It depends on the exact type of question. In this one, it's going to make it a lot easier. So let's do this. So r squared is 3/4 h squared. And then times another h. So that's 9/16. But then 9 divided by 3 is 3. So this ends up being 3 pi over 16 h cubed. Don't you think that's easier than product rule? If you could have solved for dr by dt, which is something that we've had to do in other questions in the practice, if there's a way that you could solve for dr by dt, you could do this question without this substitution. But this makes it so much easier. Easier derivative. You don't have to bother solving for dr by dt. Okay? But now we're going to just take the derivative and solve, so we'll do this quickly. Don't forget your dh by dt. I mean, you'd eventually have to recognize that's what you're solving for, so it's got to be in there. And then I'm going to sub in. H was 2. Meters per minute in this case, I think it was. What do you think? Do we get that? Another one of the observations that I make is we've talked about this before, but you look at your formula. So when I go back up to the top here, looking at this formula, which of the things in it are changing? All the variables are changing. V is changing, R is changing, H is changing. So they're not constants. They don't go away. And I think about, what do I know about them? Do I know dV by dt? Do I know dr by dt? Do I know dh by dt? If they're changing, that's going to be relevant when I take the derivative. Like, I'm looking ahead. What's going to happen when I take the derivative? It's product rule. I'm going to have a dr by dt. I don't know anything about that. So maybe a substitution will help avoid that situation. What do you think? All right, so moving on to the next one. And then again, this one's got a little bit of a twist to it. So it says, how fast is the height increasing when volume is 12 pi? Here's another one. I think we've done questions like this, so I'm going to go through it quickly. But I wish I could give you some time to think through this a little bit more. But that's why you have to go do the practice, because you got to do some of this thinking and observing on your own. I'm doing a lot of it right now. You're doing some of it, but right? When I solved this, I took the derivative. Here it is. What did I sub in for? I ended up with a dV by dt, an h, and a dH by dt. We already looked ahead and saw I don't want the r's and I don't want the dr by dt, so I substituted to eliminate that. But if I have 3 variables, I need 2 of them to solve for the third. B is still asking for a change in height to find dH by dt. dV by dt is still the same, 2 pi. This time it gives me volume. Like, what's different about this question from the last question? And it tells me the volume is 12 pi. The last one gave me h, and when I solved this, what did I do? Say again? Yeah, we subbed in the height. So do you think B is going to work out differently where I'm going to sub in the volume? Like, why would it? I'm using the same formula. I'm going to get the same derivative. Don't we need height? We're not given height. So what do we have to do? Yeah. So we got to go back and use the volume formula to find the height. And why not? So we have to find height first. We need height. So we find it first. So we've done questions like this before. But it's all about observing, what am I going to need to solve this? How's it going to work out? What do I have? What don't I have? How do I find what I don't already have? When we're doing these questions together, it all seems pretty obvious and easy, but it's not necessarily. Here's another thing. If I used this formula, 1/3 pi r squared h, and sub in for volume, I've got r squared and h. How am I going to solve for that? I know one is 3/4 of the other, but like I wouldn't be able to solve for h. So in fact, we need to use this one, which was 3 pi over 16 h cubed. Like we need to use this formula as well to solve for height. In this situation only, this formula works because the radius is always 3/4 of the height. So if I sub in 12 pi, so the pi's are gone. Let's see, the 12 divided by 3 is 4. But then, so 4, when I bring the 16 over, 4 times 16 is going to be 64. So h is the cube root of 64, or 4. Any questions? And from here, it's just identical to the first one. Yeah. Not relevant for this question. You're just asking curiosity of the fundamental theorem of algebra? Yeah, good. Any other questions? Okay, so very quickly, 3 pi over 16 h cubed. Always write down the formula before you take the derivative. You can't start with the derivative, even though many of you, I'm sure, could. So this was 2 pi. Therefore, blah, 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 blah. Any questions? One more substitution type. It's fairly different. Okay, let's get on with it then. A trough. What's a trough? What does it mean by a trough? Yeah, it can mean that.
Like kind of a curved base thing to either hold something.
Yeah, water or something like that. Usually people think like water or food. You feed animals from a trough. But we sometimes have troughs, like a ditch is a trough or something like that. But this is talking about the one that holds water. And this one's not curved. Often we think of them as cylinders, but this one's not. So it's 10 meters long, and its ends are in the form of inverted isosceles triangles that are 3 meters across and have a height of 1. Water is flowing in at a rate of 12 meters cubed per minute. What's that telling us? Again, observations? Volume, and it's the change in volume, so it's dV by dt. Again, if you want, you can write these down as you find them. How fast is the water level rising? So what are we finding? No, we've got the change in volume. How fast is the water level rising? Second. Change in height, so we're finding dH by dt. When h equals 50 centimeters, but some things in here are in meters, so we're going to change that to 0.5 meters. This one's a bit of a tricky one, so let's draw it. I think it's going to help if I keep my isosceles triangle quite wide like that. It is 3 times as wide as it is tall. It says that it's 3 meters across and a height of only 1. These can be pretty hard to draw, especially for someone like me. Not bad. That's off. That's why that's wrong. Probably looked better before. I have one too many side links. Yeah, I'm gonna have to fix this. There we go. Okay, something like that. Okay. So then we have, and I'm going to draw my water level. So the trough is 1 meter tall, but the height of the water is only half of that. So again, this seems to be talking about volume. Why is it a substitution question? What's going to be the formula for volume of this shape? Triangular prism. What's going to... So we just talked about how you can develop these formulas.
The triangle and times the length.
Yeah. So triangle is 1/2 base times height times the length. And then we start thinking about what we know and what we don't know. I've got 4 variables now. Somebody tell me something about those variables. Again, v is fine. We have dv by dt. I'm not worried about that. What about b, h, and l? So we've got h. We could find b, I think. Go ahead. Yeah, so if h is 0.5, then b would be what? Do we have that? So think about this. If, when it's full, it's 3 meters across and 1 meter in height, anywhere in the water level, it'll have that same ratio as long as it's level, as long as the trough is level, right? So the base will always be 3 times as wide as the height. I think I kind of mentioned that before, but not just if it's full, throughout the whole, at any water level. So we could find the base. It would be 3 times the height. Okay, what else? Come on, folks. What else? This is what you have to be able to do. What's the variable we haven't talked about yet? What about L? It's 10 and what about it? That's relevant to this stuff. It's not changing, is it? It's constant. It's just 10. Yesterday when we were doing these, or the day before, we were subbing 0 in. We were taking the derivative and subbing 0 in. But if I took the derivative of this right now, it would be extended product rule. It would be 3 things multiplied by each other. That would be a disaster. So in this case, 100%, I'm subbing 10 in first. The other thing that we need to know is that why not sub in for B? so that I can get rid of it and make everything simpler. What is the relationship between b and h? B is 3 times h. So I can sub that in as well. And these trough questions are kind of always like this. So this one it's harder to notice that, I know. But now that you've seen it and you'll get a chance to practice it once or twice, then you'll know that whatever ratio it gives you, 3 and 1, that's what you're going to be using, right? Okay, so let's sub in v equals 1/2 the base, which is 3 times the height times 10. So 10 divided by 2 is 5 times 3 is 15 h squared. And it went from being something that could have been extended product rule to one of the easiest derivatives you're going to take in this entire course. 15h squared. Like, my goodness, it doesn't get any easier. Actually, it might get even easier. But it's the setup. Like, the whole question is easy from here down. It's the setup, getting to this point, that is key. dv by dt is 12. H is 0.5. There's lots of little things to recognize in all of these. There's the fact that it's got a substitution that's going to make our life easier. The fact that it has a constant and that it was better to sub it in now than take the derivative first and sub in after because of how much easier it makes the derivative.